Hi, and welcome to this Palestra training video on getting to know your good friend Frame Relay. I'm going to talk about what Frame Relay is. We're going to go over all the terms associated with Frame Relay. You're going to have to know all those terms. Addressing concerns with Frame Relay, IP addressing, data link connection identifiers, and global DLCI maps, as well as how Frame Relay can handle broadcast messages. First thing we want to do is talk about what Frame Relay is and go over some of the terminology. Frame Relay is a long distance, non-persistent connection, or that's what it's recommended for through Cisco. One of the nice benefits with Frame Relay, if I have one router connection and one line to a service provider, I can connect to multiple different destinations. They can have connections between each other, or they can all route in between me, however I want to set it up. Obviously, the more connections I have, the more money it's going to cost. But it's a very flexible, very useful connection. There are certain terms associated with Frame Relay, a virtual circuit. And what a virtual circuit is, it's a logical connection between endpoints. So DTE is a data terminal equipment, which is my stuff. So that's the stuff I'm going to have on my premises. The DCE is the data communications equipment, meaning the service provider's stuff. If I work for a service provider, then this may be technically called my stuff. Anyway, the virtual circuit is the connection that's established between the DTEs from one end to another. Let me get rid of that. So that's a virtual circuit. There are two types of virtual circuits: switched, established on demand, or permanent, which is kind of like a lease line, always on. An access link is my link here, my local loop link here between the DTE and the DCE. We've got an access rate, that's the speed that I'm promised when I'm sending information out to my service provider. A DLCI, data link connection identifier. What that is, it's an identifier. It's simply a number to identify a connection or a virtual circuit between my router and another destination. So if I had a router and I had connections to multiple different destinations, even though I had one actual line out to my service provider, I would have two virtual circuits. One going to, let's call this router A, and one going to router B. I have to label these virtual circuits as something, so what we do is we just use a number. It might be 10, it might be 20, it might be 200, whatever. This number that represents this circuit is a DLCI. I also compare it, a DLCI, to a phone in my office. If I have a phone in my office, I've got 5 lines on my phone, and I can number them 1, 2, 3, 4, 5. It doesn't matter what the number is. I can number them 900, 233, 3,999. As long as each line on my phone had a different number, I would still be able to associate a line with a name. Basically, the name is the number. And that's what a DLCI is. It's just a numerical representation of a virtual circuit or a conversation. NBMA, non-broadcast multi-access. Let me clean up this slide to explain this one a little bit. This is much cleaner. So, non-broadcast multi-access, NBMA. Let me start if we just had a switch and some computers. So here's a switch. The switch is a rectangular thing. The computers are these things with the smiley faces on them. And what happens with these computers is they have direct access to multiple other devices. So this is a Multi-access environment. This computer right here has access to two other devices without having to get routed or anything like that. Direct access to two other devices. That's the part of the multi-access. The switched environment is called broadcast multi-access, or BMA if you want to be lazy, because this computer can send a true broadcast message. He sends a message that the switch receives, and that message in the header has a bunch of F's. The switch floods that message out to all other devices, so that's a true broadcast message. In the routed environment, it's non-broadcast. You can't send a true broadcast out, because what happens is, in this multi-access environment, this is the actual physical link right here. So there's one physical link going into the router. What happens is, on that physical link there are multiple virtual circuits. There's this green virtual circuit which takes us over to this green router over here, or I should say a blue router with a green square on it. And we've got this red virtual circuit which takes us over to the blue router with a red square on it. I apologize if you are colorblind. Now, each virtual circuit is its own connection. So for this router to send a message to both of these destination routers, he can't send a true broadcast. If he were to send, he can't send one message that the frame relay switch would take and send out to both different destinations. What he has to do is he has to fake it. He makes a unicast message out of any broadcast that must go out of this interface and sends two messages. He'll send one out the green virtual circuit to the green square router. He'll send the other one out the red virtual circuit to the red square router. That's not a true broadcast. A true broadcast is one message that goes to everybody. So this is non-broadcast, but it is multi-access, because with one line he has access to multiple different devices, and really he can have access to as many devices as he wants to pay for. So that's where we get the term non-broadcast multi-access. Let's look at some of those other terms. LMI, Local Management Interface. So basically keep alives and status information between our data terminal equipment, our stuff, and the data communications equipment, the service provider's stuff. So they're important messages that tell us information about our virtual circuits, as well as perform keep alive functions. LAPF, this is a long one. Link Access Procedure Frame Bearer Services. Let me just type that out. Alright, here's what we started with, link access, and this is much, much cleaner. Link Access Procedure Frame Bearer Services. What it is, it's the layer 2 encapsulation for our traffic going across our WAN links. It's a particular type of encapsulation for a frame relay line. Link Access Procedure Frame Bearer Services. Now I want to spend some more time talking about the LMI types as well as LAPF. Let's start with LAPF, Link Access Procedure Frame Bearer Services. Now, LAPF is a standard for a layer 2, and again, I'm talking about the OSI model. Layer 2, down here. So our IP packet, so this would be, if we're sending IP traffic, this would be our IP packet, thus the term packet. At layer 3, it's called a packet. Layer 2, a frame. Layer 4, a segment. So our IP packet gets encapsulated with the LAPF standard, and that has a number associated with it.